Today, we're diving into a prehistoric era that would make the age of the dinosaurs look like a walk in the park. That's right, today we're talking about the Carboniferous period, a time when the Earth was ruled by giant insects. If you think dinosaurs were terrifying, imagine living in a world where dragonflies with wingspans over 2 feet buzzed around you, and millipedes the size of anacondas slithered across the forest floor. Welcome to the Carboniferous, an era that spanned from about 359 million years ago to around 299 million years ago. The Carboniferous period is renowned for its rich plant diversity and vast swamps, which gave rise to the enormous coal deposits we know today. During this period, the continents were clustered into a single landmass known as Pangaea, surrounded by vast oceans. The climate was warm and humid, allowing for the growth of extensive forests made up of ferns, horsetails, and lycophyte trees, some of which could reach heights of up to 30 meters, 98 feet. These forests were so dense and lush that the decomposition of fallen plants couldn't keep up with their growth, leading to large accumulations of dead plant matter. Over time, this plant matter was compacted and transformed into the coal deposits that have been so crucial to humanity. The high oxygen content in the atmosphere, around 35% compared to today's 21%, not only made it easy for these forests to catch fire, but also allowed insects and other arthropods to grow to impressive sizes. This phenomenon, known as oxygen gigantism, was possible due to the way insects breathe. Unlike vertebrates, insects breathe through a system of tracheae that allow direct diffusion of oxygen to their tissues. With more oxygen available, their bodies could grow larger. Let's start with Meganeura, one of the largest dragonflies ever to exist. With a wingspan of up to 70 centimeters, 27 inches, Meganeura was a true giant of the skies. Imagine an insect with wings as large as a modern eagle's buzzing above your head. Meganeura hunted other insects and small vertebrates, using its excellent vision and powerful jaws to catch prey mid-flight. Its large compound eyes allowed it to detect the slightest movement, and its strong, flexible wings gave it incredible maneuverability. This insect thrived in the swamps and humid forests of the Carboniferous, where there was abundant water and vegetation. Fossils of Meganeura have been primarily found in Europe, suggesting that these flying giants had a wide geographic distribution. If you're afraid of millipedes, Arthropleura will send shivers down your spine. This giant millipede could grow over 2 meters, 6.5 feet long, making today's millipedes seem tiny in comparison. With a segmented body and multiple pairs of legs, Arthropleura moved with surprising speed across the forest floor. Arthropleura was a herbivore, feeding on the abundant decaying plant matter. Its strong jaws allowed it to crush the tough leaves and stems of Carboniferous plants. Despite its impressive size, Arthropleura is believed to have posed no threat to humans, as its diet consisted mainly of vegetation. This giant millipede also played a crucial role in the Carboniferous ecosystem, helping to break down plant material and recycle nutrients into the soil. Fossils of Arthropleura have been found in North America and Europe, indicating that these colossi had a fairly wide distribution. We can't forget the giant scorpions of the Carboniferous, like Pulmonoscorpius. This scorpion reached lengths of up to 70 centimeters, 27 inches, making it one of the largest scorpions ever to exist. While its sting wasn't lethal to humans, encountering one of these in the darkness of night would have been enough to scare anyone. Pulmonoscorpius lived in the same humid forests and swamps as other Carboniferous giants. It was a nocturnal predator, hunting small vertebrates and insects. Its powerful pincers and venomous sting allowed it to easily capture and subdue its prey. The fossils of Pulmonoscorpius provide valuable insights into the evolution of scorpions and their adaptation to life on land. These giants were likely very sensitive to ground vibrations, helping them detect prey and avoid predators. Among the flying insects, we also find Mazotheros, a species of giant flying cockroach. With a wingspan of around 35 centimeters, 14 inches, these creatures might have seemed like prehistoric bombers. The fossils of Pulmonoscorpius provide valuable insights into the evolution of scorpions and their adaptation to life on land. These giants were likely very sensitive to ground vibrations, helping them detect prey and avoid predators. Among the flying insects, we also find Mazotheros, a species of giant flying cockroach. With a wingspan of around 35 centimeters, 14 inches, these creatures might have seemed like prehistoric bombers. Mazotheros had a robust body and strong wings, allowing it to fly long distances in search of food. It primarily fed on decaying plant matter, playing an important role in nutrient recycling within the ecosystem. These giant insects were highly adaptable, capable of living in a variety of habitats, from dense forests to the edges of swamps. Their fossils show that they had a wide geographic distribution, suggesting they were highly successful in their time. Life in the Carboniferous wasn't limited to these giants. The period also saw the diversification of the first amphibians and reptiles, which began exploring life out of the water. Fish and other aquatic organisms thrived in the vast river and lake systems, while the forest provided an ideal habitat for an incredible variety of plants and animals. The forests of the Carboniferous were composed of plants that seem exotic to us today. Lycophyte trees, giant horsetails, and tree ferns formed dense forests that created a dark and humid environment on the forest floor. These forests were not only home to giant insects, but also to a rich fauna of amphibians that hunted and reproduced in the swamps. Why did the giant insects disappear? The answer to this question lies in a combination of factors. Toward the end of the Carboniferous period, oxygen levels in the atmosphere began to decrease. This reduction in oxygen made it more difficult for large insects to sustain their size. Additionally, the emergence of the first terrestrial vertebrates, including amphibians and reptiles, introduced new predators into the ecosystem that competed with the giant insects for resources and habitat. Climate change also played a crucial role. Toward the end of the Carboniferous, the Earth experienced global cooling, leading to the formation of large ice sheets at the poles. This cooling caused the disappearance of the vast swamps and forests that had dominated the landscape, reducing the available habitat for giant insects. The evolution and diversification of plants also contributed to the disappearance of giant insects. New plant species developed more sophisticated defensive strategies, such as tougher leaves and the production of toxic chemicals, making life more difficult for giant herbivores. These natural defenses made plants less appetizing and harder to consume for large insects, forcing them to adapt or disappear. The emergence of the first gymnosperm forests, such as pines and cycads, drastically altered the late Carboniferous landscape. These trees had deeper root systems and more resilient leaves, allowing them to compete effectively for resources and change the structure of the ecosystem. Additionally, the modern plants that began to appear were less likely to form the dense swamps characteristic of the early Carboniferous, leading to a decline in suitable habitat for giant insects. Competition and predation also played significant roles in the disappearance of giant insects. With the diversification of vertebrates, including amphibians and the first reptiles, large insects faced fierce competition for resources. These new predators not only competed for the same food, but also hunted giant insects, significantly reducing their populations. The end of the Carboniferous period was marked by a mass extinction event known as the Carboniferous Permian extinction. This event wiped out a large number of species, including many of the plants and animals that had dominated the period. The exact causes of this extinction are complex and multifactorial, but they include severe climate changes, fluctuations in sea levels, and the reduction of swampy habitats that had been crucial for the life of many Carboniferous species. Despite the disappearance of the giant insects, the Carboniferous period left a lasting legacy. The vast coal deposits formed during this time have been a crucial source of energy for humanity for centuries. Additionally, the fossils of Carboniferous plants and animals provide us with an invaluable window into the past, helping us understand how prehistoric ecosystems functioned and how life on Earth has evolved over millions of years. The fossils of giant insects and other organisms from the Carboniferous offer a fascinating glimpse into the biodiversity and ecosystems of that era. These fossils allow us to study the physical characteristics, anatomy, and way of life of these giants. Moreover, studying fossils helps us understand how changes in climate and the environment can influence the evolution and extinction of species. While the giant insects of the Carboniferous no longer exist, their modern descendants still thrive on Earth. Dragonflies, scorpions, and millipedes we see today are much smaller, but they still retain many of the adaptations and behaviors that their giant ancestors developed hundreds of millions of years ago. Modern dragonflies, for instance, still possess exceptional vision and impressive flight abilities, though their bodies are much smaller. Today's millipedes continue to play a crucial role in the decomposition of organic matter, helping to maintain the health of ecosystems. The Carboniferous era shows us the incredible ability of life to adapt and thrive under conditions very different from those we know today. From skies dominated by colossal dragonflies to forest floors traversed by millipedes rivaling the size of modern snakes, the Carboniferous was an age of giants and profound changes on Earth. The next time you see a small dragonfly or an innocent millipede in your garden, remember that their ancestors once ruled a very different world, a world where insects were kings and the Earth breathed oxygen in amounts that today would seem unimaginable. The Carboniferous era was a time of giants, of creatures we can only imagine in our wildest fantasies, a time when the buzz of a dragonfly could be as terrifying as the roar of a dinosaur. If you enjoyed this journey into the past, don't forget to give us a like, subscribe, and hit the notification bell so you won't miss our upcoming videos. Leave us a comment with the giant insect that impressed you the most, and let us know which other prehistoric eras you'd like to explore.